Welcome back to Cryptography and Network Security series. In this video, we'll be discussing about public key cryptography. So firstly, we'll start discussing the principles. We'll know what are the key concepts or key terminologies. We'll understand the public key crypto system model. We'll look into the requirements, applications, and we'll also speak about trapdoor functions. So stay tuned till the end. So let's get started. So firstly, before moving on to the public key cryptography, let me brief about symmetric and asymmetric cryptography. In symmetric cryptography, there is a plain text which is given to the encryption algorithm. There is a key, secret key provided, and with the help of this, we get the cipher text. This cipher text is again transferred to the decryption algorithm along with the key. And then we get the plain text back. This is how the cryptography works. But then, speaking of symmetric cryptography, if the keys are same, keys at the encryption algorithm and keys at the decryption algorithm, if both of them are same, then it is called as symmetric cryptography. If the keys are different, that is here if I'm using key 1 and here if I'm using key 1, such that k1 is not equal to k2, then it could be termed as asymmetric cryptography. So here exactly we'll be speaking about asymmetric cryptography. We'll be speaking about asymmetric cryptography. So public key cryptography is a cryptographic system that makes use of pair of keys. So here firstly it is a type of asymmetric cryptography. Here we'll be making use of a pair of keys. That is, one is called as public key and the other one is called as private key. So both these keys are mathematically related, but it is very difficult to derive the private key from its public key. So why do we need this? These keys are very important from the encryption perspective, and it also plays an important role in the digital signatures. Let's look into the terminologies related to asymmetric encryption. So the first terminology which we come across is a key. Key is a unique bit or common sequence, right? Common sequence of bits. So it could be public and secret or private. So secret keys or private keys, both are same here. Okay. Then we have asymmetric key. Asymmetric keys are pair of keys that comprises of both public and private, which are used for encryption, decryption, and signing and verification process. So we have seen asymmetric cryptography here. So that's what two keys are used, public, private. Then we have public key certificate. So it is a digitally signed document linking a subscriber's name to public key issued by a certification authority. So any certificate which is approved by a certification authority, and along with that a public key is also linked to it. This certificate will tell that the subscriber is identified in the certificate, has sole control, has complete control or access to the corresponding private key. So yes, then we have public key algorithm, an algorithm that uses a public and a private key pair, where deriving the private key from the public one is computationally infeasible. That's what we discussed in starting. It is very difficult to understand. Public key infrastructure, PKI, consists of policies, processes, and technology managing the public-private key pairs and certificates in the node. And in key distribution center, we have the public keys. So public key cryptography makes a revolutionary change in the cryptography because it is moving from the traditional methods like substitution and permutation. So before public key cryptography, symmetric cryptography was developed. Symmetric cryptography was in use, like DS algorithm, which we have seen in the previous video, and but it was not that sufficient or that effective. So public key cryptography fundamentally differs, right? So it makes use of two keys. So thereby it increases the confidentiality, key distribution, and authentication. Public key cryptography is not inherently more secure than the symmetric encryption, but security again depends on the key length and computational complexity. Public key cryptography heavily depends on the number theory. That is, if we have a basic understanding about numbers, it is beneficial for deeper comprehension. Right. So yeah, this was about it. So these are all the terminologies which are related to the public key cryptography. So we have spoken about what is asymmetric key, what is public key certificate, what is public key algorithm, and what is public key infrastructure. Next, let's look into the principles. So the first principle says two communicants already share a key which somehow has been distributed to them, or the key of the use of the key, the use of key distribution system center is taken. and along with that confidentiality and authentication and mathematical foundations. So first one says that dual key structure, that is public key cryptography will make use of two keys, public key, private key. Public key means it is open, it can be shared openly, whereas private key means it has to be kept private or secret by the owner. So here each key will perform a complementary operation, either it could be encryption or it could be decryption. Then we have this solution, that is key distribution center. Key distribution center addresses one of the major challenges of symmetric key encryption. That is, here this will make sure that there is secure communication without prior shared key or key distribution center. Then we can make use of digital signatures, that is public key cryptography will enable digital signatures which will provide authenticity and security and all of that. Then we have asymmetry in the key usage. So here, unlike symmetric encryption, which uses only one key, public key will use many keys, both two keys, right? So these two keys are asymmetric, meaning each key will have unique pair of encryption and decryption. Next, confidentiality and authentication. Confidentiality means sender can encrypt a message using the recipient's public key. This is A and this is B. Public key of B. Sender can send the data with the recipient's public key and he can decrypt it further. Authentication means sender can use their private key to encrypt the data or a message which can be decrypted with their public key, verifying the sender's identity. Then we have mathematical foundations. That is, public key algorithms have basic mathematical functions which rely on the number theory. We have seen that, and that's it. So this was about the principles of public key crypto system. Next we have is public key crypto system, the model. So this relies on asymmetric key structure where one key is used for encryption and the other key is used for decryption purpose. So if you see at this figure here, so both the scenarios have been explained here. Plain text is here, and this we have two persons here. First one is the sender, and on the other hand I have receiver. So sender is Bob and receiver is Alice. So Bob will send the plain text to the algorithm, encryption algorithm. So here we are taking the public key of Alice. Public key of Alice we are taking, that is public key of recipient, and sending the algorithm, sending the cipher text. So cipher text here, Y would be equal to encryption function, which comprises of public key of Alice along with the message or the plain text. On the other hand, at the Alice end, there will be a decryption algorithm. So this decryption algorithm, we need a key, right? So here I'll be making use of the private key of Alice. So here it would be decryption is equal to, X is equal to decryption of private key of Alice along with the cipher text. That's how I'll obtain the I'll obtain the plain text. So here, firstly, we are making use of recipient's public key. So we are encrypting using public key. Speaking of this figure, we'll be making use of sender's private key. So here, sender's private key. So here again I'll have Bob who has the plain text. He'll send it to the encryption algorithm. Here we'll be taking Bob's private key. So Bob's private key is taken and we find the cipher text here. Y is equal to encryption of private key of Bob along with the plain text. This is fed to the decryption algorithm. So at receiver's end, that is at Alice end, Alice will have decryption algorithm. She'll have the cipher text. She will make use of Bob's public key. Public key is easily available or openly available to Bob, right? To Alice, right? Because public key can be accessed by anyone. So public key of Joy is there, Mike is there, Bob is there, Ted is there. Here also the same. Public key of Joy, Mike, Alice, Ted is there. But then Bob is using the public key of Alice. He is encrypting the data using public key. On the other hand, Alice is decrypting the data using Bob's public key, and then she gets back the plain text here. So this is how we can perform encryption on both the ends using both public key and private key both. So in the first figure, we are making use of receiver's public key for encryption, and on the other hand, we are making use of sender's private key for encryption purpose. So this figure explains about public key crypto systems model. Next, we'll look into the 6 main ingredients of public key crypto system. So this 6 main ingredients, first one is plain text. So plain text means the original or readable message. So this message has to be transferred or it is given as input to the encryption algorithm. Next, we have encryption algorithm. Encryption algorithm will transform the plain text to ciphertext. So this process involves mathematical operations that will make sure that the message is unreadable to anyone who does not have either the public key or the private key. Then we have public key and private key. Public key means it is made publicly accessible. It can be shared by anyone. Then private key means this is kept secret. It is kept secured only by the user and only user can see it, and it can never be shared to anyone. Okay. Next we have is ciphertext. Ciphertext is the output of encryption process. So ciphertext is unreadable version of the plain text. Ciphertext is unique for each message and each key combination. That is, same plain text encrypted with different keys will produce a different message. Then we have decryption algorithm. Decryption algorithm is reverse of encryption. So here ciphertext to the plain text conversion is happening. In order to do this, we require the matching key, either public or private. So the decryption process is opposite, right? Reverse. Then we have is public key register. Public key register is like it is like a directory which keeps records. So where it is like an accessible file where users can publish their private public keys. So this allows participants in cryptographic system to retrieve each other's public keys for secure communication. That's what we have seen here, right? So here, this is the public key register. So it has Joy, Mike, Alice, Ted's public keys. Next, we have the differences here. Basically the differences. So we have conventional encryption and public key encryption. Conventional encryption means same algorithm with same key used for both encryption and decryption, whereas public key encryption means one algorithm for encryption and related algorithm for decryption and two different keys, one for encryption and one for decryption. Here sender and receiver must share same algorithm and same key. Here sender and receiver must each must have one of the matched pair of keys. They may not be the same one. Then need for the security. So here in conventional encryption, the key has to be kept secret, because if the cryptanalyst gets to know the key either from the sender or receiver, it will be very easy for him to encrypt and gather all the data. So it must be impossible or least impractical to decipher a message if key is kept secret. Yeah, this is true. The knowledge of algorithm plus samples of ciphertext must be insufficient to determine the key. Whereas from the public key encryption perspective, one of the two keys must be kept secret. That is, private key is always kept secret. It must be impossible or at least impractical to decipher a message if one of the keys is known. Yes, because the private key is kept private. So even if I know the public key of Alice, I may not be able to deduce the message. Knowledge of the algorithm plus one of the keys plus samples of ciphertext must be insufficient to determine the other key. Next we have is public key crypto systems. We know public key crypto systems will make use of two keys, asymmetric algorithms, and it will enhance the security aspect. Here we'll be looking into the public key crypto system, secrecy perspective, authentication, and combination of how secrecy and authentication is obtained. So if you see the first figure, which speaks about public key crypto systems and secrecy. So here source A will produce a plain text, that is message. Here it is denoted by X. Then this has to be transferred to destination B. We know that. Now B will generate a key pair consisting of public key. So B will generate a key pair consisting of public key, which is publicly available, and a private key, PRB, which is kept very secret. So after this is accessible by the source A, right? Suppose if you have Alice here, it is accessible by Alice. So here source A will encrypt the plain text using the public key. So here public key of B is used. Along with the message public key of B, we encrypt the data and get the cipher text. So the cipher text is sent to B. So upon receiving the cipher text, B will decrypt So B will decrypt using the private key of B itself. So after that, he'll be able to get the plain text back. So here, any cryptanalyst or attacker who observes the ciphertext of Y and who gets the public key of B and who has the access to the public key of B cannot determine the plain text X or public key PRB without the significant computational effort. So this scheme will ensure that there is confidentiality as only the intended receiver, that is B, here can decrypt the message using their public key. So that's how we can maintain the secrecy here. Next, speaking of authentication, so sender will so here the focus is on authentication rather than secrecy. Okay, so the sender A uses the private key PRA. Okay, and to encrypt the message, he'll send the public key to destination B. So sender will have private key of A, and encryption algorithm, he'll get the Y ciphertext. So ciphertext is sent to the receiver B. Receiver B will have public key of A, and along with the ciphertext, he'll get the plain text back. Now, since the message was encrypted with A's private key, only A could have created it. So this will guarantee that the authenticity of message. So it is providing a confirmation that it is originated from A itself. But this method does not protect the message from eavesdropping. That is, it could be done by the cryptanalyst. So as anyone can read the decrypted message using A's public key. So when private key is being used for encryption, if cryptanalyst obtains the public key of A from the directory, then he can directly read the message, right? So thereby this has a threat. Okay. Speaking of secrecy and authentication, when we combine secrecy and authentication, what do we get? So this approach will combine, this part is for authentication and this part we have taken from secrecy, right? So here first thing is, first encryption will happen, that is sender A will encrypt the plain text with their private key PRA. So first encryption is happening here. After that, we'll do the second encryption for confidentiality purpose. So here the resulting ciphertext Y is encrypted using receiver's public key, that is PUB. So here it was PRA, here it is PUB. Again, after that, I'll have the ciphertext Z. So it is a final ciphertext that will have both authentication and confidentiality. Then it is transferred to B. On B's end, B will for the first decryption, he'll make use of the private key of B here. So by this we can be sure that only B is accessing the data, or B is accessing the ciphertext. After that, the next step is again double decryption. He'll again make use of public key of A. So if attacker knows the public key of A or public key of B, then he may not be able to decrypt the message, because he will also have to require the private key of A and private key of B. He cannot say that I am Alice or I am Bob, that is I am either sender or receiver, then fake man in middle attack, such thing cannot work here. So here it is two-factor authentication sort of a thing is being practiced here, right? So after that, the message is obtained in the receiver's end. So this method will ensure confidentiality, that is only B can encrypt the message using their private key, and authentication is by maintaining the integrity that it was encrypted by A's private key, and any modification of the message would require A's private key, which is kept very secret for A or within A itself. So secrecy will make sure that only intended recipient can read the message. But there is leverage to the recipient's public key for encryption. Then we have authentication will guarantee that message's origin and integrity by encrypting with the sender's private key. Then authenticity and secrecy is this, which we have discussed now. So moving on further, we'll look into the applications. First one is encryption and decryption. So sender will encrypt a message using recipient's public key. So this is one of the application. Then we have digital signatures. Digital signatures means sender signs a message using their private key, allowing the recipient to verify the sender's identity and message integrity. Then we have key exchange. In key exchange, two parties will collaborate to exchange session key, typically involving one or both parties' private keys. So let's look into the requirements. Okay. So the first requirement is about key generation. That is, it is computationally easy for party B to generate a pair of public key and private key. That is, public key and private key should be generated. Next, it is about encryption. So sender A, knowing public key and message to be encrypted, M to generate corresponding cipher text. That is encryption purpose. Then next we have the decryption purpose. So here the recipient should be able to recover the original message from the ciphertext using private key. So private key to the original message. Then next we have is infeasibility of key recovery. That is, it should be infeasible for any third man to, although he knows the public key, to determine the private key, it has to be very difficult for him or impossible for him. And next, along with that, it is infeasible for the third person to know the public key and ciphertext and recover the original message. So we can add sixth requirement, that is, although useful, it is not necessary for all public key applications. Sixth necessary is order of key application. The two keys can be applied in either order, that is public key and private key, or private key or public key. We have seen this in secrecy and authentication part, right? So yeah, this is about asymmetric encryption. So what is encrypted with one key, public key, can be decrypted with another key. If it is encrypted by public key, it has to be decrypted by private key itself. Or if it is encrypted by private key, it has to be decrypted by public key of that same person. So here is the mesh topology in which, or the directory, public directory in which the public keys are easily available or accessible by all of the users in that network. Next, we'll speak about trapdoor functions. Trapdoor one-way functions. So one-way function is one that maps a domain into a range such that every function value has a unique reverse, with the condition that calculation of function is easy, whereas calculation of inverse is impossible. That is, y is equal to f of x is very easy, whereas x is equal to f inverse y is impossible to obtain. That is only one way. Either you can go, but you cannot get back. Okay. Next, trapdoor one-way function, which is easy to calculate in one direction and infeasible other way unless additional info is known. It could be calculated in polynomial time with additional info. This is rare case. So a trapdoor function is a family of invertible functions such that y is equal to f of x is easy, x is equal to f inverse y is easy when k and x are both known. If any one is known, then it is infeasible. So this is what the one-door function speaks of. So here we have covered major important points. So if you have any doubts in public key cryptography, then do let me know in the comments. Next video will be speaking about the RSA algorithm. So stay tuned, subscribe to my channel. Thank you.